Hi, my name is Virapat Pitmanakam. This video presentation is for Chapter 2, Application Layer. For this chapter, we talk about Introduction to Application Layer, Client-Server Paradigm, Standard Applications, Peer-to-Peer Paradigm, and Socket Interface Program. The application layer is the layer 5 on TCP/IP protocol suite. For this layer provides services to the user, and it is an imaginary direct connection through which they can send and receive messages. So this is a picture for a logical connection at the application layer. So for this LAN on application layer, we'll connect to another application layer on another LAN. So the internet was originally designed to provide service to users around the world. Since the application layer is the only layer that provides service to the internet user, it allows new application protocols to be easily added to the internet, which has been occurring during the lifetime of the internet. And on the application layer, it has standard application layer protocols and non-standard application layer protocols. Application layer paradigm. For application layer paradigm, we need two application programs. So the both application programs can able to request services and provide services. So for application layer paradigms, it has traditional paradigm, client server in the past. And in nowadays, new paradigm, peer-to-peer. And the last one is mixed paradigm. So this is the example of a client server paradigm. So in the picture, every LAN in this picture will connect to a server. And this is the example of a peer-to-peer paradigm. So in this picture, this LAN will communicate with this LAN, and this LAN communicate with this LAN, and this LAN will communicate to this LAN. For client-server paradigm, in this paradigm, communication at the application layer is between two running application programs called processes, a client and a server. A client is a running program that initializes the communication by sending a request. A server is another application program that waits for a request from a client. Application programming interface. A computer language has a set of instructions for mathematical operations, a set of instructions for string manipulation, a set of instructions for input-output access, and so on. We need a process to be able to communicate with another process. We need a new set of instructions to tell the lowest 4 layers of the TCP/IP suite to open the connection, send and receive data from the other end, and close the connection. A set of instructions of this kind is normally referred to as Application Program Interface or API. So it has sockets, socket addresses, and finding socket addresses, server side, client side. So position of the socket interface is between application layer and the lowest 4 layers. A socket used like other source and sink. So for normal source, keyboard read, and application program will write to a monitor or a sink. So it's like other source and sink. It has to read and write. And then we use sockets in process-to-process communication. For this picture, we have client process and server process. For client process, we send a request to a socket, and then a socket at client process will send a request to another socket at server process by logical connection. And then at a socket on server process will request to server process, and then server process will respond back to a socket, and then a socket will send a response to a socket at client process by logical connection. As you see, a socket responds back to client process, followed by a request from client process. A socket address. For a socket address, it has two parts. For the first part, its IP address, it has 32 bits, and the second part is port number, it has 16 bits. So let's see the example 2.1. We can find a two-level address in telephone communication. A telephone number can define an organization, and an extension can define a specific connection in that organization. The telephone number in this case is similar to the IP address, which defines the whole organization. The extension is similar to the port number, which defines the particular connection. Using services of transport layer, a pair of processes provide services to the users of the Internet, human or programs. A pair of processes, however, need to use the services provided by the transport layer for communication because there is no physical communication at the application layer. There are three common transport layer protocols in the TCP/IP suite. It has UDP, TCP, and SCTP. Standard client-server application. During the lifetime of the Internet, several application programs have been developed. We do not have to verify them, but we need to understand what they do. For each application, we also need to know the options available to us. The study of these applications can help us to create customized applications in the future. World Wide Web and HTTP. In this section, we first introduce the World Wide Web, abbreviated WW or Web. We then discuss the Hypertext Transfer Protocol or HTTP, the most common client-server application program used in relation to the web. So, for World Wide Web or WW, it has architecture, Uniform Resource Locator (URL), and web documents. And for Hypertext Transfer Protocol (HTTP), it has non-persistent versus persistent connections, message formats, conditional requests, and cookies. And web caching, proxy server location cache update, HTTP security. Let's see example 2.2. Assume we need to retrieve a scientific document that contains one reference to another text file and one reference to a large image. Figure 2.8 shows the situation. The main document and the image are stored in two separate files in the same site, file A and file B. The reference text file is stored in another site, file C. Since we are dealing with the three different files, we need three transactions if we want to see the whole document. So this is a picture for example 2.2, retrieving two files and one image. So a client requests to site 1, and site 1 it has A and B. So client requests to 1, and then site 1 respond to a client. Client gets file A, original document, and then a client requests again on the site 1, and then site 1 respond back to a client. A client gets file B, image, and then client request 3 or request to site 2, and then site 2 request back to a client, and client get file C, reference file. For the browser, so the browser at controller it has HTTP, FTP, SSH, SMTP, and HTML, JavaScript, and Java for interpreters. For example 2.3, the URL http www.mhe.com/comsci/Forazon defines the web page related to one of the computer in the McGraw-Hill company. The path is comsci-Forazon, which defines Forazon web page under the directory comsci. So let's see example 2.4. So for this example about how client and server communicate. So for this connection is non-persistent connection. So this connection it has 3 handshake messages. So let's see how it works. Client, it has first handshake to a server, and server has second handshake back to client, and then client has third shake plus request to server, and then server respond back and client get file. And after respond, a client do first handshake again, and then server second handshake back to client, and a client third handshake back to a server. So all of these is first connection in non-persistent, and then a client do it again, do a 3 handshake message. So after do 3 handshake messages, a server respond back an image file to a client, and then client do 3 handshake messages again to a server, and all of this part is of non-persistent connection. And example 2.5 show the same scenario as in example 2.4, but using a persistent connection. Only one connection establishment and connection termination is used, but the request of the image is sent separately. So for this example, it's like previous example. So a client do 3 handshake messages like the previous example. So it has first handshake to a server, and server has second handshake to a client, and a client has third handshake plus request to a server, and then server respond back to a client, as a file. And a client requests to a server again, and the server responds back to a client as an image file. And then a client do 3 handshake messages again to a server. The connection between a client and server. So this is a connection of client and a server with persistent connection. And then we talk about formats of the request and response messages. So this is the request message, and this is a response message. So look at this line. It is request line, and this part is request headers, and 2 of these are request message header. And for this part, at the bottom of the box is request message body. And this is the method of request and response message. And this is request header names. And this is a response header name. Example 2.6. This example retrieves a document. We use the get method to retrieve an image with the path /usr/bin/image1. The request line shows the method get the URL and the HTTP version 1.1. The header has 2 lines that show that the client can accept images in the GIF or JPEG format. The request does not have a body. The response message contains the stated line and 4 lines of header. The header lines define the date, server, content, encoding, MIME version, which will be described in electronic mail, and length of the document. The body of the document follows the header. So this is the picture of example 2.6. So a client requests to a server. It uses get method /usr/bin/image1 http/1 to 1. So accept image/gif and accept image/jpeg. And then a server responds back to a client by http/1 to 1 200 OK. So this message box is show that a request that a client sent to the server is success. So it shows date, server, content encoding, and content length. Example 2.7. In this example, the client wants to send a web page to be posted on the server. We use the put method that the request line shows the method put URL and HTTP version. There are 4 lines of headers. The request body contains the web page to be posted. The response message contains the stated line and 4 lines of headers. The created document, which is a CGI document, is included as the body. So this is a picture of example 2.7. So a client requests to a server with put method. So for this message box is a request, and then a server responds back to a client with this message box. So it shows 200 that is success. Example 2.8. The following shows how a client imposes the modification data and time condition on the request. So this line is a request line by get method, and this line is header line. The stated line in the response shows the file was not modified after the defined point in time. The body of response message is also empty, like this. Example 2.9. Figure 2.15 shows a scenario in which an electronics store can benefit from the use of cookies. Assume a shopper wants to buy a toy from electronics store named Best Toys. The shopper's browser or client sends a request to the Best Toys server. The server creates an empty shopping cart or a list for the client and assigns an ID to the cart. For example, it is 12343. The server then sends a response message which contains the images of all toys available, with a link under each toy that selects the toy if it is being clicked. This response message also includes the set cookie header line whose value is 12343. The client displays the images. So this is a picture of example 2.9. So a client will request to server by get method to besttoys.com, and then server will create a customer file with ID 12343, and then a server will send a response back to a client, and then a client will get a vendor file with cookie 12343, and then the client will request back to a server with cookie 12343, and a server will respond back to a client by this response is about representing the price, and after that server will update a customer file for ID 12343, and then a client request image by get method to a server. So for this request is about information about the payment, and server respond back to a client to for order confirmation to a client, and then a server will update uh, a client file ID 12343. So this is an example of a proxy server. For the summary, applications in the internet are designed using either a client-server paradigm or a peer-to-peer paradigm. In the client-server paradigm, an application program called a server provides services, and another application program called a client receives services. A server program is an infinite program. A client program is finite. In a peer-to-peer paradigm, a peer can be both a client and a server. The World Wide Web, or WWW, is a repository of information linked together from points all over the world. Hypertext and hypermedia documents are linked to one another through pointers. The Hypertext Transfer Protocol, or HTTP, is the main protocol used to access data on the World Wide Web. Thank you for watching.